Many programming applications will require the use of two-dimensional arrays rather than a one-dimensional array. You generally need to use two subscripts to identify any type of data that's in a table, where data is arranged in rows and columns. Many applications come to mind, such as an insurance rate table or a tax table. Provided are the two general forms of declaring a two-dimensional array. The first example is to declare an array with a name just as you would with a single-dimension array, and then provide two subscripts. The first subscript is the upper subscript for the row, and the second one is the upper subscript for the column. Again, just like single-dimension arrays, this is not meaning the number of rows, the number of columns, but rather the upper subscript. And of course, just like with single-dimension arrays, you also need to specify a data type, which is going to dictate what type of data can be stored in that array. In the second example, you see again the name of the array being specified after the word dim, but in this case you see a set of parentheses with only a comma in between. The comma inside the parentheses is necessary to specify there are two dimensions to the array. You specify the initial values with the first dimension and the second dimension for the column. The compiler will determine the number of elements from the initial values that you supply. So by specifying the name of the array and then leaving the parentheses open without a specific subscript, you're allowing Visual Basic to determine the size necessary. Again, you need to specify the data type, as with all cases. Here are two examples of two-dimensional arrays. In the first example, we have an array called last name string with subscripts of 3, 5. The 3, 5, the 3 represents the upper subscript for the rows, where the 5 represents the upper subscript for the columns. This array, called last name string, can hold up to 24 names. 24 names because there are 4 rows and 6 columns. Note that the 3 represents rows 0 through 3, where in the column the 5 represents columns 0 through 5, therefore making 4 rows by 6 columns, for a total of 24 names. In the second example, we have an array called age integer, which is going to create an array which is capable of storing integer data type. This particular array can hold up to 50 whole numbers. 50 whole numbers because there are 5 rows and 10 columns. Again, note that the 4 represents 0 through 4 rows, and the 9 represents 0 through 9 columns, therefore making this array a 5 by 10 array capable of storing up to 50 numbers. Once two-dimensional arrays have been declared, the elements of the array may be used in the same way as any other variable, such as with counters and accumulators and reference fields for lookups and so forth. And just as the same as with single-dimension arrays, you have to be concerned about not exceeding the bounds of the array. That is, in the case of age integer, you could not reference a row outside of the upper subscript of 4 or a column outside the upper subscript of 9.